gaming industry is a global industry which generates billions of dollars in revenue every year. At the forefront of innovation in this industry is Bally Technologies. Bally Technologies is the oldest slot machine manufacturing company in the world, but that does not stop them from continuing to create new technologies and user experiences every chance they get. One such technology is their iGaming platform. Through this platform, Bally offers casino operators the ability to augment their land-based casino gaming with mobile and online play for free and wager-based games. By partnering with internet gaming providers such as Game Account Network, Bally hopes to expand their player base by offering video slot content online. However, the game development process is long and expensive, and having to develop the same game twice, once for a physical slot machine and once for mobile platforms, is not ideal. Therefore, Bally would like to use the same game on both systems. This is where Pinch comes in. Bally has the ability to bring a web browser up on a physical machine. However, it has no connection to the machine itself, specifically the hardware. A player who sits down at one of these machines should not be able to tell that the game is playing in a browser, as the user experience should be seamless. This means that the printer, bill validator, doors, etc. need to interact with the web-optimized game as they would a normal game. Pinch allows us to make this a reality. It uses TCP socket communication to relay messages between the server and the client, or slot machine, allowing hardware to function normally. Pinch is divided into three main parts. The first is a demo game written in HTML5. This is hosted on the server. The second part is the Pinch backend. It handles all communication between the game and the slot machine. It also hosts a database containing persistent variables for each machine, as well as possible machine states and actions. Finally, on the client side, we have the interface. It performs all client-side operations and handles communication between the server and the current operating system on the slot machine. This operating system has direct control over the slot machine hardware. First, we will discuss the demo game. As Bally has not yet implemented web-hosted games, our team needed to port an existing game to HTML5 in order to properly demo our project. As you can see, the game behaves normally. We can increase the bet, we can view the pay table, and we can play. However, when we attempt to play the game on a PC, we receive a connection error, as the web game requires communication with a slot machine in order to continue. The server backend consists of PHP scripts to perform communication and database queries, as well as the database itself. We use asynchronous server calls to continuously query the database and communicate with the slot machine and relay any information, including current states, errors, and the bank value to the demo game. The database consists of three tables. The first is the cabinets table. This table contains information about each cabinet or slot machine registered to the system. It includes a unique ID, the IP address, the MAC address, the current bank value, the current state, the current tilted value, and whether or not the machine is connected to a web game currently. A tilt occurs when the machine is suspended for any reason, such as a door opening. The next table is the state filter. This table associates states with a unique integer ID. We use this filter because integers are easier to compare than string literals. The final table is the actions table. This table associates PHP function calls to a unique integer ID, as well as a brief description of the function and the required number of parameters. We relay our desired action ID to a script, which queries the database and calls the appropriate function. The final component of Pinch is the client-side interface. It is installed as a game manifest on the machine and immediately attempts to open a TCP socket to the server, then relays any messages from the server directly to the operating system. Because the operating system has direct control over the hardware, this interface bridges the gap between the server and that hardware. Also, any messages from the operating system are relayed to the server in the form of action IDs, as we discussed earlier. Here we will see Pinch in action. First, we insert $10 into the bill validator. The machine validates and updates the bank value. There is now $10 on the machine. We play the game and see that the hardware lights flash, showing that we are playing. We have played 2 games at $1.50 each, leaving us with $7. We then press cash out. The printing voucher message is displayed and a ticket is printed. A cabinet tilt message remains until the ticket is removed. We can see that the ticket has the correct bank value on it. Thank you for watching. Again, Pinch was designed by Team 6, including Tice Jordan, RJ Machado, and Robert Roeder for CS426 Senior Projects in Computer Science at the University of Nevada, Reno, spring 2013, with Professor Sergiu Dascălu and external advisors Saurabh Singh and Garrett Hill from Bally Technologies. It represents hundreds of hours of work and over 4,000 lines of refined code using C++, MySQL, PHP, and HTML5.